Today, we are going to be talking about integral concrete waterproofing with the Sika WT240P. Throughout our discussion, we'll take a look at the differences between crystalline and hydrophobic admixtures, when to use which, and cover the benefits of each product. My name is Paul Lasky. I'm the National Manager of Concrete Innovation for Sika US. I've worked in civil infrastructure and concrete for the past 15 years, with areas of focus in bridge and tunnel projects, stormwater management, high-rise applications, and deep foundations. I'm a proud member of the American Concrete Institute, the National Precast Concrete Association, and the American Shotcrete Association. Thank you for joining us today as we delve into an important part of understanding the products that are available to us when deciding how to best protect our projects and developing specifications that are critical in determining the life of our structures. Caspar Winkler, the founder of Sika, was driven by his entrepreneurial spirit when he laid the cornerstone of our company back in 1910. He was born into a modest cobbler family and immigrated quite early from Austria to Switzerland. There he invented the Sika 1, a quick-setting waterproofing admixture for mortar, which was used to waterproof the Gotthard Tunnel, enabling the Swiss railway company to electrify this important connection between northern and southern Europe. Today, the new Gotthard Tunnel, also called the New European Alp Transit, is again an important project for Sika. Although Sika 1 is still part of the product range, much more advanced products are being used today. High-tech admixtures for shotcrete and tailored waterproofing systems are needed to build this more than 35-mile-long tunnel, the longest tunnel on Earth, through the Swiss Alps. We can be proud of our history and look to the future with optimism, as our know-how, our service, and products are now needed more than ever. Sika's innovation has repeatedly met demand. When Sika was in its early development, Caspar Winkler recognized an upcoming global need for his trailblazing admixtures and launched subsidiaries around the world. In the 1930s, there were already 15 Sika subsidiaries in Europe, the United States, Argentina, Brazil, and Japan, establishing new construction chemical markets. During World War II, Sika companies continued production in every country where they were present. As a result, the admixtures for the bunkers built in Switzerland and in the German-occupied areas were delivered by Sika. And also the Sika admixtures for the concrete ships used by the Allies to transport material to the land in Normandy. Since January 2013, Sika's business is aligned in several target markets: concrete, waterproofing, roofing, flooring, sealing and bonding, refurbishment, and industry. It is also important to note that research and development units are established for each target market. Sika invests heavily in developing new technology, as evident in all of our divisions. As of 2020, Sika now has subsidiaries in 103 countries, sales of $8.9 billion US, and 25,141 employees worldwide. We are listed on the Swiss Stock Exchange under SIK. The fully integrated concepts offered by Sika address the entire life cycle of a facility, from initial construction up to the point in time when repair, refurbishment, or extension become necessary. Sika develops and markets a complete range of admixtures and additives for use in concrete, cement, and mortar production. These products enhance specific properties of the fresh or hardened concrete, such as workability, water tightness, durability, load-bearing capacity, or early and final strengths. You may even be familiar with some of our brands and products. Here is a photo of construction workers applying Sika 1 back in 1930 in New York City's famous Penn Station. While the personal protection equipment and application methods may be a little different, Sika's products still have a very viable role in today's projects. Sika has a deeply rooted history in waterproofing admixtures, and today, our innovation is still proving to shape the future. Sika's improved crystalline admixture, the WT240P, not only outperforms the competition, but pushes others to perform in ways not previously identified as critical in construction. But we'll get to that in a bit. Now let's get on to our presentation. One example of where Sika's crystalline admixtures have been used that you may be familiar with is the Lincoln Memorial Reflecting Pool in Washington, D.C. Sika was chosen as the premier crystalline waterproofing admixture to ensure that our national monuments will be built right the first time and stand the test of time. Another, more recent installation was in Greenpoint, New York, where the WT-240P was used as a standalone component for the waterproofing requirements of a basement in a high-rise apartment complex. This was located right next to the Hudson River. It's also important to note that the WT-240P has great packaging, with 1 bag added per cubic yard of concrete. Its volume is 2% by volume of cementitious, roughly 12 pounds per cubic yard. The WT-240P is well suited for wastewater treatment plants and dams as well.
Water has the ability to penetrate concrete by traveling through its pores and small cracks due to capillary action or hydrostatic pressure. Capillary action is the method by which surface tension and surface attraction moves water along the walls of a pore or crack. This is a great chance to illustrate the properties of each type of admixture. Crystalline will pull the water into the concrete and help create the formation of crystals. Hydrophobic will repel the water from the surface. In order to simplify the concepts we are reviewing, we're going to look at a two-phase system of how the industry typically creates watertight concrete. Phase 1. We want to reduce the water-cement ratio. This is typically done with a superplasticizer. This would be Sika's Viscocrete line. This will reduce the water-cement ratio, therefore reducing the amount of capillaries. In Phase 2, we are now looking to block the remaining capillaries. In today's example, we're going to be looking at the Sika WT-240P and Sika Watertight Concrete Powder. Let's look at our two options in review. First, crystalline PRA technology, Sika's WT-240P. Crystalline enhanced concrete is activated by the presence of moving water. These products are hydrophilic in nature. This means they absorb water, or the opposite of hydrophobic. The main component of this PRA is that crystals will form within active pores and capillaries to block and stop the movement of water. Crystalline has the ability to self-heal cracks. This is important to understand once a crack is formed. The crystalline will activate and keep the concrete structure from incurring more damage as a result of water moving through the structure. This technology is great in higher hydrostatic pressure environments. This is the term crack bridging that you may have heard. Once a crystalline PRA is introduced into the concrete mix, it is good for the life of the structure. Its crystallization will not stop occurring regardless of the age of the structure. The structural component will not be compromised if the outside is scraped. This can occur with bituminous or membrane coatings. The product is available with a tracer element to show that the PRA has been added to the mix. This is typically a red tracer element. Now let's look at the Sika Watertight Concrete Powder as a hydrophobic PRA technology. This PRA helps to repel water. If you've ever seen rain beat up on the outside of a new jacket or umbrella, this is the same concept. The repelling component is based off of increased surface tension. Water is repelled off the surface rather than being absorbed. This technology is not great in higher hydrostatic pressure environments. The structure will not be compromised if the outside surface is scraped, such as with bituminous or membrane coatings. As mentioned on our last slide, the WT-240P is available with a tracer element. Our WT-240P Red has an additional 4 pounds of red color added to the mix. Standard packaging of the WT-240P is in 12-pound bags. This is typically around the required 2% of cementitious content. Our tracer element product has a total weight of 16 pounds per bag. Our current specification requires a minimum cementitious content of 590 pounds per cubic yard, with a maximum water-cement ratio of 0.42. the Sika WT240P at 2% plus Viscocrete as needed for slump. Again, this is 2% of cementitious material. Or we can use the specification of the Sika watertight concrete powder at 2.95 pounds per cubic yard, and we suggest a target slump of 6 inches, or SCC may be utilized.
Sika prides itself on the amount of research and development it partakes in each year. As a member of the Target Market Concrete team, I'm proud to interface with our amazing R&D division on a regular basis. With Sika's headquarters in Lyndhurst, New Jersey, the R&D lab plays a large role in our success. We regularly monitor our products and customer mix designs to ensure that we're delivering the best product to our customers and into the market. In order to understand how this department works, and specifically how the WT240P was developed, please allow me to introduce a key member of our team.
My name is Ana Jimenez. I have worked 20 years experience in the construction area and 14 years working in Sika Corporation in R&D and Mixture Lab. Current position as a regional project manager in the Mixture Group for North America and LATAM. R&D Lab in US has 13 employees that works to support and develop a mixture for the whole concrete group. It is important to highlight that for new products, we spend all the time needed or required to obtain the product that it meets expectations from the market. During the development of the WT240P, R&D focused in two major things. One of the first one that we were focused was the permeability reduction. For this, it was different methods that they already set up around the world. So that one is covered by the test method that they are in the market. The second main point for us was the crack healing. For that one is when it's no test method around the market and it took us more time to develop. Let's say that powder and mixtures is not in our daily assignments. Normally, as everybody know, mixtures are liquid, and this for us was a new challenge in the R&D group. Our main focus was to develop a method to evaluate crack healing. The time consuming to create an internal procedure to check the crystal and compare it multiple formulations, it was a process that it was developed through the months. First thing that we had to do in this case was to create a mortar mix design that we were able to evaluate the crystal group. After that, we find out that we had to simulate the current conditions in the field to see how the crack will be healing, and that it was made by the mortar cubes. Prepare the samples and demold them after 24 hours. Then we had to cut them, create a crack. That makes a journey to start to explore different ways to see how we submerge the cubes in water to get to the point that it was the condition needed for the evaluation. find out how long it took to see the crystal to grow through the crack was the truly challenge. This sometimes for us, it was in the wait of 7 to 2 weeks. Check weekly the process of the crystal using microscope, taking pictures. Sometimes was going weekly or sometimes was going daily. It depends on the formulation that we were evaluating. During the process, there were many formulas that they were discarded due to different reasons, too much crystals or too little. That depends on the chemical composition that we were evaluating. The method showed us that crystal growth through the crack and filling all the gap. That was the main concern for us. The crystal growth method showed to be consistent with the results obtained on the field. That was our truly challenge and our truly success.
We are now going to look at the results of third-party testing for our WT240P versus comparable products on the market. We're very proud to share the results of the testing, which proves our crystalline waterproofing admixture is truly a best-in-class product.
Let's take a look at what adding common waterproofing admixtures in the market has on slump and air. First, when looking at slump, we always want to see a minimal impact to the mix. With the control mix at a 4.5 slump, we see the least impact and only admixture to tighten the mix up as the Sika product. All other products will loosen the slump anywhere from 1/2 inch to 1 3/4 inch. Air content is critical, especially in the northern climates, where again, we're looking for minimal impact, and as we can see, the Sika product delivers a 0.3% decrease in air content. This is very stable when looking at the range of results across competitors. The set times are very interesting when looking at the products in the study. The Sika product is the only product to show the initial set time decrease when compared to the control sample. Some products have close to an additional 2 hours to reach initial set times. It's also great to see that the smallest deviation from the control sample in final set times. We can see a 45-minute increase in final set times versus worst case scenario of 195 minutes with a few of our competitors. Compressive strength is an important component in both concrete and shotcrete applications the same. It directly relates to the overall strength and durability of a structure.
As we look at the graph on the right illustrating 28-day compressive strength results, we see that almost all products have some type of beneficial effect, increasing the compressive strength. The Sika product, however, tests above the average for overall strength gains when compared to the 3 additional products.
3 of the most common tests used to evaluate the effectiveness of waterproof concrete are the ASTM E96 standard test method for water vapor transmission of materials, the ASTM C1585 rate of absorption in water, and the DIN 1048 testing of hardened concrete water permeability. We're going to explain each test and review the results. Again, all of the data being reviewed is third-party testing, looking at several products in the market, including our own. Starting with the ASTM E96 standard test method for water vapor transmission of materials, this test applies to any material, not just concrete. As a known mass of water is placed in a vessel and covered by a semi-permeable material, in this case concrete, the loss of water over time is going to illustrate the permeability of the material into water vapor. We are looking for the lowest value represented to indicate the best performance. In this case, the lowest rate of vapor permeability in the sample. It's easy to see that the Sika product has the lowest and best-in-class vapor permeability. Let's also take a quick look at the hydrophobic watertight concrete powder in the same test. You can see an additional 5% improvement in water vapor transmission rates with our crystalline product over our hydrophobic product, which is the watertight concrete powder. The ASTM C1585 test. This measures the rate of absorption of water. This test method is used to determine the rate of absorption of water by concrete by measuring the capillary travel of water. As we discussed earlier, the capillary travel is severely reduced by using viscocrete and then further reduced by using a permeability reducing admixture. The 1585 test is important to notice that this is conducted under a non-pressurized condition over an extended period of time. And what we're looking for is a lower absorption rate means a better water resistance. Looking at the Sika product in the graph illustrated, you can easily see that we have the best-in-class performance when looking at ASTM C1585. Lower values indicate better performance. Again, when Sika stacks up to common products in the market, it's clear to see that we have some great results. Let's also move over to a comparison on how the product compares to a hydrophobic product. Again, this is the ASTM C1585 test, where we look at the crystalline Sika WT240P versus a hydrophobic product, which is the Sika watertight concrete powder. With your control sample, you're going to notice a 73% improvement over a 50% improvement with a hydrophobic watertight concrete powder. So significant advantages when looking at this test using the WT240P. The DIN 1048, testing of hardened concrete for water permeability. In contrast to the ASTM C1585 test, this test is representative of head pressure. Essentially, the test applies water pressure against a concrete section. We're going to look at a constant head pressure in excess of 150 feet of water applied for over a 72-hour period. The results will illustrate that a lower penetration will mean a better water permeability resistance. Let's look at some third-party testing illustrating the results of our product along with several competitors in the industry for DIN 1048 water penetration testing. It's clear to see that Sika's WT240P is best in class. This type of test is important to recognize, especially in deep foundation environments. These are high hydrostatic pressure environments where the WT240P thrives. You can translate this into dam and wastewater treatment plant applications as well. You might be asking when to use what product. The WT240P has superior characteristics in many applications, but there may be applications that you would use the watertight concrete powder to benefit your product as well. Let's look at the WT240P. You need active water movement to activate the crystalline growth. Any application where crack bridging is required. This is the term you might have heard about with self-healing concrete. The product is available with the tracer element. This is great in water storage applications and construction joints. Related to wall-to-floor connections, the WT240P is better. This product is NSF 61 certified, and it's best in shotcrete as there is little effect on set times. Most crystalline products that you can see as a result of our test earlier can have negative effects on initial and final set times. Now, with watertight concrete powder, it's not available with a tracer element. You may want to use this for water storage facilities and floor joints, as the watertight concrete powder is better for active joints that may have some movement. This product is also NSF 61 certified. Critical flooring applications where fast curing is required, essentially when you're trying to reach a relative humidity of 85% or less, prior to applying a critical flooring application, the watertight concrete powder can be a great component. The watertight concrete powder is best to prevent the absorption of environmental moisture. It's also best in freeze-thaw applications, reduces permeability, and the WT240P, it's good to notice that the crystalline occurs within the capillaries. The watertight concrete powder is going to try and prevent any water from ever reaching the capillaries that are exposed. Thank you for your time today. We're proud to share the performance results of the WT240P when looking at some common products available in the market. Know that we have a dedicated concrete representative in your area that can help with specifications, application-specific details, batching, and placing of our product. My contact information is listed below if you should have any questions on today's content. Thanks again for your time, and we'll see you along the way.